Good morning, everyone. Thanks for attending the talk. I know I'm the last thing before you get fed for lunch, so I'll try not to bore you to tears. This talk is about networking, securing the network, and then network security. So I know that they're related terms. They sound like they're the same, but they are not. Trying to make sure that everybody knows what I'm going to cover. I'll introduce myself, talk about why this talk came about, what I'm not going to teach you, and then we'll go through networking, network security, and a couple other pieces. So first thing about me, working for SyCom Technologies here in town. I'm the lead security consultant. Before that, I was a consulting engineer on the networking team. Previous to that, I worked for a health system here in town for over 15 years in network and network operations. So got a good foundational knowledge about networking, wanted to share it with you today. Small warning, like I said, my dad was a sailor in the United States Navy, so on occasion I slip. I'm trying to get better, especially now that I've got kids at home. I am not perfect. So why am I doing this? It's not just because of the shiny badge, I promise. So networking is fundamental and it's foundational. And what I mean by that is it is involved in information security in every step of the way. And it's one of those things that I kind of feel that many folks don't get it. It's a black box to them. It just magically, I just hit the button for Netflix and then my show appears. I have no idea how it works. It's just magic. Well, it's not magic. There is lots of technology involved, lots of theory involved. So I'm going to try to share with you some of the key points when it comes to networks in general. This is something else, having been at a large company in the networking team, one of the things I found out was the security teams didn't necessarily understand how the network worked, so their take on the best way to secure the network wasn't necessarily something that was workable or would give them the results that we mutually were seeking. And all the security stuff is hard. Let's not make it any harder than we got to. So this is certainly not going to give you enough information to go past CCNA or become an expert network operations guy. It's also not going to teach you about how to tune intrusion detection boxes, things like that, firewalls. We just kind of glance off that stuff because we only have 50 minutes. So networks. So we'll kind of break it down, what it is, why we have them, and then where they might be. So really what a network is a way to communicate. That's really what it is. We've had networks for 100 years. Before we had computer networks, we had a phone network. So you could pick the phone up, dial the operator, or dial direct, and reach somebody else. So fundamentally, we had networks because we wanted to communicate. That's why we have them. And now we've got networks to let devices, and of course people, certainly, communicate with other resources. And they are everywhere. So I guarantee you have a network device probably in your pocket or on your belt right now. Looks like this, it's a cell phone. This is a network device. Because without the network, this really is just dead weight. Well, I can probably tell you the time, but so could a watch. So how do we do all this wonderful stuff? Like, how does all this stuff work? Well, of course, it works with equipment. All that fancy gear with got big kind of logos on it, you pay a lot of money for it, all that kind of stuff, that's how we make this work. But really, that fancy gear is using some theoretical models to pass the traffic back and forth to actually make this stuff work. So before we go crazy talking about gear and this and other thing, we're going to talk about a theoretical model that's kind of the basis of how you can approach understanding as well as help to inform your troubleshooting process. So traditionally everybody talks about the OSI model, and I'm going to too. And I know up front, and I'll tell you now, this does not match 100% to how IP works, to how TCP IP works. Similar, a little different, but good way to break down some of the different layers, some of the different pieces and parts that are involved, and help you with your understanding. So first layer, most fundamental layer, is the physical layer. So we're talking about wire. We're talking about fiber optic. We're talking about how the actual bits of information get sent back and forth. Data link layer. So this is a layer to determine how we're going to exchange those little bits, those little bursts of information. How are we going to agree to talk? So obviously, as an example, I'm talking English, and hopefully you understand me. My accent isn't too bad. But if I was up here and I was trying to tell you this talk in Latin, well, you wouldn't understand me. But that's the job of the data link layers, to make sure that we're talking in an acceptable way. Networking is starting to move more away from the fundamental and more to the logical or the abstract. This is a way that we're going to resolve pathing in a lot of cases. Transport is an additional way to help us with pathing, as well as giving us methodologies to best exchange information. And this is where, again, the theory and the practice gets a little murky. So you can make arguments that certain things that we use today, let's say email. So how does email get transferred? When you hit send on your cell phone, what's the stuff in the background that happens? Well, there's multiple protocols in play, and you can make arguments that they fall into different places here at the very top. So we've got session at 5, we've got presentation at 6, and very last and least, we have actual applications at 7. So this is your web browser, this is your email client, this is your point of sale system. All that stuff is applications, of course, running and utilizing on the network. So these are the technical layers of the OSI model. In a lot of cases, there's actually more than 7 layers. So there's actually 10 layers of the OSI model. So layer 8 is politics. Layer 9 is finance. And layer 10 is religion. I know people laugh at that. Well, I worked for a faith-based organization. Religion was in play. So here's some real-world examples of what I'm talking about here. And you can see here, so I've got the layers broken down. I've got the data unit. So think about this. This is the collection of data that I'm passing back and forth and how it's done. And then I've got some examples here for you to try to get your head around how some of this stuff works. So again, we start at the bottom talking about bits. So signals on a wire, light pulses, radio waves. That's the physical thing of getting this stuff back and forth. When we move up to data link, it's framing. So again, we are agreeing at a very low level on how we are going to exchange this information. The most common example we have today at layer 2 is Ethernet. Now there was stuff that came before. There was things like Token Ring. There was things like ArcNet. Most of the stuff has gone away. What we're seeing today is Ethernet, and then we're seeing IP here at layer 3, the networking layer. And now we've moved into packets. There are other networking technologies. So I got IPX, SPX here for all the folks who might remember Novell a long time ago. There was actually things that Apple did up here as well. But again, what's happened is IP has taken over the world. So that's what we talk about in most cases. As we move up in layers, now we're going to deal with datagrams. So it's, again, this is a logical construct of information that we are exchanging. Most common things that we see at layer 4, TCP, Transmission Control Protocol. So it's a protocol used to maintain connection state back and forth. So this is where the famous SYN, ACK, and acknowledgement, the three-way handshake comes in as TCP. UDP is a loss protocol. I just dump it out there, and if it makes it, awesome. Doesn't make it, I don't care. You can deal without it. User datagram protocol is what that stands for, by the way. A couple other ones that are here that are probably going to be important for security folks to know is ESP and AH. So ESP is encapsulating security protocol. So this is an encapsulation method to protect the confidentiality of the information that might be sent across a link that you don't trust. So VPNs use ESP. Now there was an earlier technology that was just talking about integrity, and that was AH, which is authenticated header. Don't see a heck of a lot of that anymore because the actual data is still sent in the clear. All we're doing is we're verifying that the sender is indeed who was sending it, who we expected to send it. And you can see we're moving up here We've got sockets and ports at layer 5. Again, this is where it becomes nebulous because the OSI model doesn't 100% match up with TCP, with the IP model, I should say. Presentation, again, some examples: TLS, transport layer security, SSL. It's the stuff that protects you when you go to Amazon, to buy that cat toy, to get that movie. It's all done here to protect you, confidentiality with TLS and SSL. Last thing, application-wise, HTTP, good example of a protocol that's also an application. And of course, you're going to see applications reference things like Outlook, Secure CRT, PuTTY, so on and so forth. So, got some examples of what we might expect to see when it comes to the actual equipment, the actual physical things we're talking about to make all this stuff work. So again, layer 1, cabling, Cat 5, Cat 6. Yes, there were categories before that. That's what that stands for, is category. There was actually category 1, 2, and 3. Not really any 4. Did exist, don't see much of it. At this stage of the game, you're going to run into Cat 5, Cat 5e, which I believe stands for extended. Cat 6, there's Cat 6a, their standard, and now also discussion about Cat 7. Primarily the reason we have 6 and 7 is for higher speeds, 10 gigabit Ethernet as a signaling rate. And again, this is to support just the explosion of devices. So more than likely, like I said, everybody here, I'll bet you got a cell phone. Some of you probably have a tablet with you, a laptop computer. So all we've seen in the networking realm is more and more devices wanting to have access, wanting to utilize the resources that networks connect together. So moving up to layer 2. So here we've got switches, bridges, access points, and hubs. Now almost everything is a switch. You can go to Best Buy, spend $40, buy a switch. It's actually hard to find a hub. And hubs are actually important for security in some cases, and I'll touch on that in just a little bit later. Same thing with bridges. I don't think I've actually seen a bridge in production use now for over 10 years. Access points for wireless, they actually here are working at layer 2, though they may have layer 3 type features. And you can see here on my network layer, I've got a little thing that says multi-layer switches. You think to yourself, well, if a switch says layer 2, why is it also at layer 3? Well, as time has gone along, what we have seen is the ability of devices to do more, to expand their capabilities. So that is why we've kind of seen somewhat of a fuzziness about what the different pieces of equipment can do for you. So certainly a firewall can also be a router. In some cases, it's also got a switch in it. It's all these devices in one physical piece of gear, and it's because we have got an explosion of processing power and capabilities that, of course, grow every day. Then towards the top, what we're seeing, got firewalls. You might see, go out to the vendor realm, talk to some of the guys, Palo Alto, Fortinet, Cisco, SonicWall, list goes on and on. They go, oh, we make next generation firewalls. What was wrong with the old generation? Well, what they're really talking about is the ability to have visibility into the content that's passing through the firewall. And then, of course, at the end, application layer equipment that we expect to see. Well, it's it's your PC, it's your tablet, your cell phone, the stuff that you're actually using an app on to do something. So, how's this stuff work? What's it doing for you? So, hub forwards out of every port. Garbage in, garbage out. So from a security perspective, if you're on a hub, wherever you send, I get a copy of 2. You may not want me to have it, but I get it anyway. Switch is a little different. So switch is, you maybe excited a smart hub. So a switch is going to learn addresses and then forward from the source to the destination and not tell anybody else. A router is the same thing. It learns, but it's worried about the network layer. It's all about layer 3. It doesn't care what the hardware address is. It cares what the logical addressing is. And then, of course, our famous firewall. It's only told to allow certain things to happen. Again, this is a layer 3, or a layer 3, 4, 5, 6, 7 thing. Now, there are ways to do firewalls at layer 2. But let's not get crazy. We only have 50 minutes. And we could talk about it, and you'd be bored to tears in probably about 40 seconds. So we're not going to do that this time. So, We've talked a little bit about how this stuff might communicate, and of course we have to establish pathing. So there are a couple of ways that the industry has designed to help you with pathing. So the two great examples at layer 2, actually example at layer 2, spanning tree protocol, STP in some cases, you might hear people refer to it as that. And then at layer 3, it's routing protocols. But before we go too much into pathing, let's talk a little bit about addressing. So layer 2 is about MAC addresses. Media access control is what MAC stands for, not Macintosh. So in computing, we love acronyms because we have so many of them. And we use the same ones to denote different things. That's the great part about this. So a MAC address is a 48-bit number, hexadecimals, as you can see. And you might see it represented different ways. So this is one of the things, so if you go to your Windows machine and you ask for it, you're probably going to see, well, depending on your version, because what's the use of standards when you make your own, you might see it with dashes, you might see it with colons, you can see here, or one of the manufacturers of network gear loves to use groups of 4 separated by a period between each group of 4, which is great, except for the fact that other times when you do this on their same equipment, it shows you to you a different way. Reasons, I guess. Layer 3, IP addresses. Everybody knows, oh, what's your IP address? Just go to Google, type in, what is my IP address, mash enter. Google will tell you what your IP address is. Really easy. 32-bit number, which in the grand scheme of things isn't very big when you kind of think about it. Shown as base 10, there are ways to represent it in base 16. Only programming guys do that because they think they're cool. No, if you're making it too hard on the rest of us, please stop. And then, of course, we figured out 32 bits of addressing wasn't enough because we reserved some of it. We did some other stuff to it. We did a really good job handing it out. We kind of messed that up. What's our solution? We'll just make more. So IPv version 6, 128 bits. And no, I do not know what happened to IP version 5. I don't know. Can't tell you. Of course, you can see, this is kind of hard to read, a little harder to see. This is only important from the standpoint, this is where people are going, this is where the industry is moving to, and lots of security tools have been focused on IPv4. They don't know about 6. They have no idea about 6, which at one point wasn't a huge deal, but this started to become a problem when Microsoft decided, hey, there's a new thing. We should ship that. That's a new feature. Well, IPv6 doesn't need a bunch of other stuff to make it work. It can kind of figure things out by its own in some cases. So what we found out is, by default, starting with Windows 7 and moving on to Windows Server 2008, ship with IPv6 enabled, which was great. Stuff communicated, used IPv6, everybody was happy. The security tools, however, they missed that kind of stuff. I have been present myself at a couple of attacks where IPv6 was used and nobody saw it because the tools didn't understand them. Yeah, that was an oopsie. So I know you're thinking to yourself, well, that was great. Why do I care about addresses anyway? You just told me Google will tell me my address. Well, you have to know them to communicate with other hosts. If you saw the talk yesterday, there was a gentleman from Infoblox talking about DNS. And DNS's job was to resolve a name that humans know to an IP address that a computer needs. So of course, we need an IP address. We need to know how to talk back and forth. So we'll talk about how this thing works. And again, IPv4 on Ethernet to make this simple and straightforward. So I am IP address 192.168.1.10. I want to go to .20. What do I do? So what I'm going to do is I'm going to check this. I'm going to basically check with the information that I have, and I'm going to determine, is this here with me? Can I reach it on my same segment, or is it somewhere else? So I'm going to see, is this here? Oh, it's this here. Great, it's a local address. So I'm going to send a broadcast. I'm going to send an ARP. ARP is Address Resolution Protocol. If you're on a Windows machine and you want to know what ARPs your machine has, go to a command prompt. May they never die. type in ARP space -A, mash enter, tell you everything it knows. So I'm going to ask, send to the world, hey, I need to know the address for 192.168.1.20, please tell me. That machine will respond to me, hey, I'm this. Awesome. So now I know where to send my stuff to. So I'm going to send it frames, source from my hardware address to their hardware address, and then, of course, we profit. So now you think to yourself, this is probably pretty easy, sounds good. One thing to keep in mind, MAC addresses need to be unique on the layer 2 segment that they live on. Many, many years ago, I worked for a computer store. The guy who owned the place loved getting stuff cheap, which was fine, no big deal. He got a great deal on network cards to be bought for this large order for a computer training center in town. And they were training on Windows NT Server. I'm probably dating myself here. Anyway, Windows NT Server. They called up, we delivered the computers, everybody was happy. They called up 3-4 days later in the middle of a class and said, hey, folks are loading NT Server, and about halfway through the process, after we get about 3 or 4 machines, they just freeze up, don't work. So of course my boss is like, you gotta go out there, take a look at it, see what's going on. I'm like, okay, go out there, ask some questions. I said, all the machines, they have 20 of them in this classroom. This is kind of weird behavior. I said, so what's going on? He's like, well, if I use this one and that one and this one, then I have the problem. But I use these 4, they always work no matter what I do. I'm like, this is weird. So I started trying to play process of elimination. Well, I figured out, my boss got a deal. So of that 16, whatever it was, machines, 3 network cards had a MAC address. Everything else, the MAC addresses were all zeros. Oops. It was a great deal. I think he saved, 70 cents a network card. It only cost him 6 hours of my time. So I'm sure he came out ahead. So this is all forwarding at layer 2. It's all switching. So as I said before, switches learn based upon what they get sent, what they see as physical addresses, MAC addresses, again, layer 2. And we build this by learning. So the potential red team people in this room are probably thinking to themselves, hey, I bet I can mess with that. And you'd be right. But hold on to your horses quite yet. So, we want to talk. We want to get to the famous Quad 8 server, which is Google's DNS server, by the way. And yes, Google logs what you do to that server. Just keep that in mind. They say don't be evil. They apparently forgot about that a while ago, but discussion for another day. So, I'm checking my network out. I'm going to tell Nikon to go away. Thanks for nothing. Okay. This is a remote address. Well, I can't do it myself. I need the help. I need the help of a layer 3 device. I need a router to help me out. Or it's maybe a router in Canada. It's always so strange you talk to somebody north of the border. I want to check my routing table. I have one. Probably doesn't have anything in it besides my default, but I got one. Check my routing table. What am I going to use? Oh, by the way, Windows route space print to your routing table. Works on all versions. Well, probably doesn't work in Windows 3.1 and DOS, but anyway. I need to send my traffic to the gateway for this guy. So I'm going to ask ARP again, hey, I need the MAC of the gateway. Somebody hook me up. I'm going to get it. I'm going to send my frames sourced from my MAC to the gateway's MAC. But granted, at a higher layer here, I'm going to have the IP addresses. So the gateway's going to get this, and it's going to go, well, I don't have this either. I'm going to check my routing table and figure out where to send this. So the gateway runs through these first 5 steps again. And this happens so on and so forth until we get to the very end and we profited again. Awesome. So this is forwarding at layer 3, routing. Generally, routing is all about best path selection based on destination. normally. There are other things you can do to make it route by source address and things like that, but again, we could talk about them probably for days, and you'd be bored at the end of it, and I'd be hoarse. So we're going to just kind of let that go for now. Maybe I'll talk Jake into a Network 201 class next time. We'll see. And a routing table, of course, is a list of known networks and their paths. Basically the next stop, the next hop, the next step that I would take. So, done with networking. Awesome. I'm not doing too bad. Okay. So let's talk about securing all this stuff we have to make it work. Because as you can imagine, some brilliant attacker somewhere has thought, you know, if I could mess with their network, I could do all kinds of fun things to them. So, of course, we have invented security processes to help us out here, thankfully. Layer 2, as I talked about before, mentioned briefly, spanning tree protocol. Spanning tree is an algorithm. There's lots of math involved. No, I don't know it. I know how to make it work. Spanning tree is all about building a loop-free topology. So you can plug stuff in kind of any way you want. Spanning tree will work through it, figure it out, and go, okay, this is what I'm going to use. This is how it's going to go. Now, small caveat. The $40 switch that you buy at Best Buy doesn't understand this. Just keep that in mind. So you use those little boxes everywhere that could cause interesting things. I had somebody one time go, you know, if one connection is good, then two has got to be better, right? Yeah, except for spanning tree doesn't like that. It was fine. So spanning tree is here to keep us safe. Make sure there's no loops. If there's a loop, we stop. If I get these BPDUs, which is Bridge Protocol Data Unit, if I get them from somebody else, then I know there's another switch over there. So depending upon what's going on configuration-wise, I might say, nope, I'm not going to do that, I'm going to block it. Or I might go, hey, that's somebody I expect. I'm going to tell them what I know. Because ultimately what we're doing is we're building a topology, which is, you can think of a topology as a logical map of the paths available to you. Of course, again, we like standards in computing because, you know, lots of different options, modes of spanning tree. Default is just plain spanning tree. Then, of course, we had to get rapid. Got to be faster, rapid spanning tree. And we did per VLAN. VLAN is a virtual local area network, and there's a bunch of stuff to talk about there, but again, don't have much time. And then, of course, Cisco, because they're the Microsoft of the networking world, did their own stuff for rapid per VLAN and multiple. Talked about bridge protocol data units. We're going to send them out configured ports. Make everybody know we're here, trying to make sure that we can detect a loop. Now, of course, there are protections here, because they can be used for good, they can be used for ill. So generally what we're going to do, we're going to make sure that we've got in places that we do not expect another switch, probably going to enable BPDU guard. We're going to say, well, if I get a BPDU in, not supposed to be there, sorry about your bad luck, and the answer is no. Go away. We're going to turn the port off. Of course, same configurations and architectures really help you out here. In a lot of cases, networks get built organically. They grow, they change, they mature. But it's always good to have an idea in your head of what your overall architecture is and what your goals are. And then, of course, something else, physical security. Lock the closet door. Don't let people in. Don't put the wiring closet in the restroom. Don't snicker. It happens an awful lot. Or the janitor's closet. I always love that one. You know, it's up there, 10 foot in the air. Yeah, I left my jetpack at home. All right, so pathing, layer 3, it's all about routing protocols. Okay, not routed protocols. So routed protocols are things like HTTP, you know, web traffic, SMTP for email. That's a routed protocol, something we're sending. Routing protocols are something that helps us figure out where to send things to. So, of course, got some industry standards that are out there. RIP, which is Routing Information Protocol, one of the first ones. Don't see it much anymore. It works. Yeah, it's got, we'll just say, some concerns, some issues. There's 2 versions of it, too, by the way. So OSPF, a couple versions of that. It's open shortest path first. BGP, or Gateway Protocol. Don't worry about these acronyms, because I'm just doing this like I'm trying to remember for my CCNP test. ISIS, intermediate system. These are all industry standards. And then, of course, our friends at the Big Teal Bridge had to make their own, so we got EIGRP. Generally, all this stuff works like 3 different ways. We've got distance vector, we've got a path vector, we've got based upon link state. And then we can break them down further into 2 different, I'm going to call them types. Interior, inside your private network. Exterior, beyond your trusted perimeter, let's just say. And of course, each one has its own way to do things. One thing's key from a security concern is that neighbor relationships in most cases are sent in the clear. Might be a problem there, just a thought. We don't authenticate routing peers in some cases. That's not a default. Because we trust everybody on the network, right? It's like totally okay. Like we're never going to have a red team guy show up and plug into a port and go, hey, wow, I see a routing protocol broadcast. I bet you it'll make me a neighbor and give me a full routing table, and I can tell leadership that I know their entire network. You know? Like I said, routing protocols do broadcasts, which means they go everywhere. So, of course, what we need to do? Well, we're all about minimizing our risk. Barry did give a great presentation about risk, identifying risk, managing risk, talking about risk. Well, risk is everywhere. He wasn't kidding. It's even in your network. So what are you going to do? Like I said, minimize your broadcasts. You're going to authenticate your routing peers. You're going to encrypt your links that traverse things that you don't trust. Consider some other guidelines here. Like I said, there's actually 2 best practices documents that the IETF has put out, 38 and 84. What we found out is most folks don't follow them because I'm not really sure why. But if you saw the news article, I guess now 6-8 months ago, where all of a sudden a whole bunch of traffic that was bound to, it was either Google or Microsoft, went to the Ukraine and back. Now that's because someone didn't do those 2 things. If they had done that, it wouldn't have happened. And at the end, like I said, Barry talked about risk. You and your network team, think about kind of game plan out. How might somebody try to take a chunk out of me? How would I potentially prevent that? Also consider the failure scenarios. So, am I worried about a backhoe eating my fiber? Am I worried about a power outage? Am I worried about somebody breaking into my closet? Go through that, figure out what your risk is, and how you're going to work to mitigate that concern. Of course, you want to harden the devices themselves. I mean, honestly, even though it's a switch, it is kind of a computer inside of it. You can take control of it. You can do things to it. Routers, firewalls, the same way. I mean, you're telling it to do things. So what are you going to do? Not going to run everything on it. There's no reason to run that ident server or that old finger protocol for whatever reason on your stuff. Turn the stuff that you don't need off. You're going to want to control and audit administrative access to the device. Keep logs. Because you're getting logs, right? You're doing that. That's probably the number one thing I see. I come to a place, do an assessment, ask questions. Hey, do you have logs? Well, we did. We don't really do anything with them because there's just an awful lot of them. Okay. Fair enough, I guess. If there's a hardening guide, read it, follow it. Sometimes it's just general stuff. Sometimes it's actually good stuff based upon a certain platform. Sometimes the manufacturers have a general guideline, oh, do this stuff. Okay. But again, that gets you onto the path of making yourself a harder target. Patch upgrade device code. Like I said, this stuff, it's a computer inside all that stuff. No matter what it looks like, it runs software. Got to patch it, got to update it. I know guys are like, oh, my network core has been up 900 days. It's so awesome. It's like 5 years of vulnerabilities you haven't patched against, dude. Thanks, that's awesome. And then, do not filter ping. I've had this argument more times than I should about people like, people can discover things with ping. Well, you're right. But ping is a inherent way, so ping is actually part of a protocol suite called ICMP, Internet Control Message Protocol. It's a way for hosts to tell each other that there's something wrong and how to work around it. If you filter it, that stuff breaks. Don't do that. Okay, almost done, almost lunchtime. So, network security. Why are we securing the network? Well, we secured the network itself. Now we're talking about how to further our ability to put controls onto this underpinning, this foundational system. Networks touch everything. They're everywhere. In some cases, you can't mess around with people's endpoints. Like, people don't like you to touch their cell phone. They don't like that. So, of course, if all you have is the network, put network controls on there to help you figure out what's on my network, what's it doing, and am I okay with that? So, all about defense in depth. Again, this is risk management. So generally I've broken down network security in a couple of categories. These aren't official because the network security industry kind of as a whole is, I'll just say, a little weird sometimes. So primarily what we're doing here, we're talking about visibility and surveillance. We're not talking about the creepy guys in the van surveillance. Network access and segmentation controls. And then enforcement of your policies onto the network. This is a little bit of an eye chart. I'm sorry. I tried to make it not too bad. Categories and examples here. So visibility. What I put in here is features, so things you might reasonably expect to already have in your infrastructure that you can leverage. Don't have to spend any more money on them. Probably makes all the vendors sad, but it should make you happy. So visibility, we can do things, packet captures, we can get AP detection, we can get logs. Syslog's a great thing. For network access, we got captive portals like here at VCU. You come on VCU's wireless, wants you to sign in, wants you to accept terms and conditions. That's a captive portal. DHCP snooping is on here as a feature. You can extend that with various other mechanisms. If you saw the talk yesterday from the gentleman from Infoblox, he was really talking about how they have made up an ecosystem to prevent attacks based upon the very beginning of someone coming onto the network. And the very beginning of network access is what they're doing with DHCP-based protections. And then, of course, enforcing our will, or enforcing our policies. So we're doing that with access control lists. We're doing that with firewalls, with IPS, sandboxes, all kinds of fancy stuff is helping us enforce our security policy. So all this fancy stuff, lots of vendors want you to sell to their latest whiz-bang Mach 3 widget that's so awesome, it does all this stuff. All right, great. So how many folks do you have working in your security department? What are they doing? And how much gear do you have to take care of? So think about how all these different pieces and parts can play together and integrate. Because let's be realistic, you probably don't want to work 20 or 22 hours a day. It's not an awful lot of fun. So make it easy on you. Think about also how you're going to update it, how you're going to take care of this thing. If it's a great system, but it requires hand holding and you don't have the time to hold the hand, you're going to get a return on your investment? Probably not. Think about how hard it might be to get, again, that money you're spending back. So in general, you're like, okay, where do I put this stuff? So you told me, make sure it all integrates, buy this stuff, put it in, watch it, use it, leverage it. Okay, where do I put it? So certify your architecture based upon your level of risk. It was great. You probably talked to Barry. Probably saw Barry's talk, right? Nod your head, yes. Okay. I know this doesn't really help. This is a total CISSP slide. You know, nothing really true and concrete. It's all nebulous stuff. Oh well. That's probably now the third badge that I've broken. Anyway, you know, where are your assets? Okay. Ooh. Okay. So really, where you want to put this stuff, certainly on your internet edge, between you and all those bad guys, assuming that they're on the outside, and they're not always. Maybe on your inter-network edge, extranets, vendors, VPNs. This is something that Target probably should have done. Probably would have saved them an awful lot of money, and the CEO would probably still be working there, by the way. Maybe inside your data center, if you have one. You know, if you're 100% in the cloud, you're going to have to deal with that. And then, of course, think about all the wonderful encrypted traffic that goes across your network that you can't see inside of. What's in there? Is it for people you trust, going to places that are okay? Or is that ransomware beacon going out to some place in the Ukraine to steal all your stuff? So just keep that in mind. So, how are you going to do this? You're probably thinking to yourself, man, this sounds really hard. I'm going to go do something else. I'm going to go drive a truck for a living. It's got to be easier. So, think about what you got. You know, take stock of what your assets are. Think about how you can leverage them. Close the gaps that give you the biggest bang for the buck. So again, Barry was in here talking about risk. So that stuff that was like 125 in his risk register, do that first. Leverage what you got, do that stuff first, then you work your way down. Not rocket science, not hard, and do not let the enemy, don't let the enemy of good be perfect. I've dealt with this in the past. Propose the system, we'll do this, you know, it's limited, but it'll help us. And I got told, well, that's not going to be really helpful because it only captures 7 days worth of data, and we need more than that. I'm like, okay. So nothing was done. A month and a half later, law enforcement comes to our door and says, we need every log you might have for this period of time because we are investigating a multi-state fraud case in the millions of dollars. Yeah, didn't have anything. That was a fun conversation to have. But why did you have anything? Well, we were told since it wasn't perfect not to bother. Well, we would have had something. Don't be afraid to start slow and small and begin to build your momentum. If you're a security professional, engage the network team. I will bet you they've probably been asking for stuff that you're asking for too. They've probably been asking longer, and they would love your help. So, that was almost it. Awesome. Okay. So, want more references. One of the great things now is all kinds of great information there on the internet. Stuff like Safari Books Online, YouTube, various people's blogs, tech sites, conferences. If you want to get more deep into networking, I recommend some of the CCNA study stuff. Even though it's potentially going to lock you, or maybe think you lock you into Cisco, there's still good foundational information in there. You know, routing and switching doesn't change no matter whose label is on the box. So it gives you good foundational knowledge to use for something else. So that when I go to a customer, they're like, hey, we use Brocade. I'm like, okay. I'm not going to know the syntax, but I'm going to be able to read it and make sense of what's going on because I know what to expect on a network. Wikipedia actually has great information, amazingly enough. There's a great book for TCP. It's TCP/IP Illustrated. I think it's volume 3 now. I have a copy of 2. Serious geek cred there if you can read it all and not fall asleep. I use it as a reference in a lot of cases when people are like, oh, it does this. And I go, well, it's not what the standard says. Did find a great FAQ at Ars Technica about networking. So, I got a little time left? Yep. Woohoo, 5 minutes, awesome. So, questions, comments. Don't throw tomatoes, this is a clean shirt. Emily wore twice. Well, that was easy. All right, so this is me. Like I said, I work for SyCom. Send me an email. I put LinkedIn links. I don't do Twitter. I don't have time for that. I don't do Facebook. I don't trust those guys at all. So here you go. Thanks.